Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to solve previous year question paper related to K-set, covering the concepts cyclic coordinate as well as Poisson bracket. Okay, let us start with first question. The first question says QK is said to be cyclic coordinate. If they are asking QK is said to be cyclic coordinate, then which of the options are correct? Okay, we shall solve according to the Euler's-Lagrange equation. That is, we have d divided by dt of dou L divided by dou QK dot minus of dou L by dou QK is 0. This is nothing but the Euler's-Lagrange equation. QK is said to be cyclic means I have explained in the previous video. This term, entire term becomes 0. If this entire term becomes 0 means what is remaining? D divided by dt of dou L divided by dou QK dot is nothing but 0. This dou L divided by dou QK dot, what we have is it is nothing but momentum, right? So from this equation I can say the momentum is conserved. Understood, right? So which of the option is correct? This first option is itself correct. That is dou L divided by dou QK dot dou QK is equal to 0. So this is the definition for cyclic coordinate. From cyclic coordinate we can say that momentum is conserved. Let us go to the next question. If the Lagrangian of a mass is given by this. F being a constant, then x of t can be obtained in terms of constant C1 and C2. Okay, this is bit a difficult question. Let us solve this. What they have given? They have given the Lagrangian. First note on that Lagrangian. Lagrangian is nothing but half of the m into x dot square plus xf. So apply this Lagrangian on Euler's-Lagrange equation. This is the Euler's-Lagrange equation, right? So apply on this. So it will be d divided by dt of dou L. Here instead of qk it will be x dot, right? Qk dot, it will be x dot minus of dou L divided by dou x, which is nothing but 0. We know that dou is nothing but the partial derivative. If we do the partial derivative, my x will be constant if I do with x dot. If I do with x, x dot will be constant. Right or wrong? Yes, it is right. So, what is remaining now? D divided by dt of dou L divided by dou x dot will be half of the m into 2 times of x dot, right? 2 get cancels. What is remaining now? M into x dot will be remaining minus of partial derivative of L Lagrangian with respect to only x. X dot remains constant. What is left now? Xf. Differentiative of x is 1. So what is remaining? F is remaining. This is equal to 0. So it will be complete total derivative of mx dot, right? Total derivative means if we do, what we get? M into d divided by dt of m here constant, it will come outside. D divided by dt of x dot will be x double dot, right or wrong? Minus f, which is equal to 0. So this is the equation of motion we got. So on integrating this equation of motion, we can get the x of t, that is x, it is depending on the t it represents. We can get x. So shall we do that? So mx dot, which is equal to f, can I write like this? Yes, I can write. Here m into x double dot, it will be constant, that is f, right? So if I take m to be my right hand side, it will be x double dot, which is equal to f by m. Now what I need to do means I want the value of x. So if I want the value of x, I need to integrate. So on integrating both the sides, I'll get x. So on integrating this equation 1, so I'll get x dot, which is nothing but f divided by m into dt will be there. No, on integration of dt, it will be t, plus after integrating one constant will arrive. That constant will be c1. Okay. Again on integration, again on integrating this equation 2 will get x. How? This x dot is nothing but d divided by dx divided by dt, right? So it will be dx, which is nothing but f divided by m into t. Previous only I did the same thing. Now I am explaining little clearly to understand. Okay. So dx will be, on integration it will be x. So x will be f divided by m. This is f divided by m as constant. Integration of t with respect to dt is t square by 2 it will be, plus c1 into dt. C1 is itself a constant, into dt means c1 into t it will be, plus again one more constant will arrive, that is c2. So this is the solution. So which option matches here? Cf divided by 2m t square plus c1 into t. They have said it to c2 into t. It is fine. Plus c1, right? So option C is the right answer. I hope that you people understood. I am going to the next problem. So what does the next problem says? This is a very important problem. For which values of alpha and beta is the following transformations? This too is the following transformation is a canonical transformation. For that we have a equation. We have a equation. That equation I am going to write. Using that equation we can say the value for alpha and beta. Okay. So we have the equation is dou q divided by dou q and dou p, that is capital P, that is a new coordinate, divided by old coordinates, that is small p, minus of dou q divided by dou p and dou p divided by dou q, which is nothing but 1. Whatever we get, we need to equate it to 1. So they have given a q and they have given a p as well as p. So first we shall partially uh, partially derivative we shall do this. Okay. So partial derivative of q with respect to small q, what we'll get? Alpha into q and alpha minus 1 it will be, right? And what they have given is, there they have made a mistake in the question itself. While solving I got to know here it should be p. Okay, here it should be small p, or else we'll not get the answer. Here it should be small p, or else we'll not get the answer. So for this they have given the grace marks, that you can see. This was asked in 2018 case it. They have given the grace for this. So if I do beta, and beta is constant, p will be constant here, because we are doing the partial derivative with respect to q, right? So cos of beta p remains as it is, and do the partial derivative of p with respect to p, q alpha remains same, and sine of beta p, it will be cos of beta p. Partial derivative of beta p, it will be p, right? It will be beta, right or wrong? Yes. Minus of dou q divided by dou p. So we need to do with respect to p. So q of alpha remains same as it is. Cos of beta into p, if you derive derivative of this, it will be minus sine of beta into p, and beta will come, right? Next what we have, p with respect to q, partial derivative of p with respect to q. So it will be alpha into q of alpha minus 1, and sine of beta p remains as it is. So equate this to 1. So on rearranging the terms we will get, we have alpha here and beta. take it, uh, keep on one side, and here we have q of alpha minus 1 and q of alpha. It will be q of 2 alpha minus 1, right? Q to the power of 2 alpha minus 1. And cos of beta p, cos of beta p, it will be cos square beta p, right? Minus of, the same thing happens here, alpha and beta is remaining, keep it on one side. And what is remaining? Q of 2 alpha minus 1, and minus of minus, it will be plus, so it will be plus sine square beta p, it is equal to 1. We know that from the identity cos square x plus sine square x, which is equal to 1, right? Rest of the terms here is constant. So if I take common, alpha beta q to the power of 2 alpha minus 1, constant. What is remaining? Cos square beta p plus sine square beta p, that is equal to 1. So which will be 1. This is the equation what we got, alpha into beta q to the power of 2 alpha minus 1, which is equal to 1 we need to get. So start with the first option. So keep the alpha value off and beta value 2. So our LHS should be equal to RHS. Let us take the first option and we shall do. Okay, keep the alpha value off and beta value to be 2, and q to the power of alpha value is of minus 1. So we are considering the LHS and we are doing. Okay, it will be minus 1, a minus of minus 1. So which is equal to half of get cancels. Here also half of get cancels. What is left? Q to the power of 1 minus 1. Q to the power of 1 minus 1 is q to the power of 0. Q to the power of 0 is nothing but 1. So this is our RHS, right? LHS, which is equal to RHS. So first option here is correct. So first option is the correct option. So there was a mistake in the question, nothing else. Let us move to the next question. Let, they have given Poisson bracket of a comma b denotes the Poisson bracket between a and b. Then Poisson bracket of a comma b comma c minus Poisson bracket of a comma b comma c is equal to. This we can solve using the Jacobi identity. What does the Jacobi identity says? Poisson bracket of a comma b comma c plus Poisson bracket of b comma c comma a plus Poisson bracket of c comma a comma b is equal to 0. First, what we have? Poisson bracket of a comma b comma c, right? Here this only we have, minus of Poisson bracket of a comma b comma c. See, the commutative Poisson bracket does not follow the commutative property, that is Poisson bracket of a comma b is minus of Poisson bracket of b comma a. That we know, that I have explained in the previous video, you can go and watch. So Poisson bracket of b comma c comma a, can I can I write commutative property of this? Yes, I can write a comma Poisson bracket of b comma c minus of Poisson bracket of c comma a comma b, it will be, right? And I will also commutate this one. It will be Poisson bracket of a comma b and Poisson bracket of c, which is equal to 0. Can I shift this a comma, this c comma Poisson bracket of c comma a comma b to my right hand side? Then what we have? A comma b comma c, it will be minus of Poisson bracket of a comma b comma c, which is equal to Poisson bracket of c comma a comma b. Is it right or wrong? So what they have given, this is the question they have given. What should be my answer? The answer should be Poisson bracket of c comma a comma b. Is it right or wrong? Yes, it is right. So what should be my option? Option 2 is right here. Everyone understood? I hope everyone is understanding. So I shall move to the next question. What does the next question says? The physical quantity that has the same dimension as the action S in the Hamilton's principle is? Action S is defined as, like, action S, what is the definition for action S is integration of Lagrangian with respect to dt. Our limits, we have a t initial to t final. So this Lagrangian into dt, that takes the physical quantity that has that same dimension of orbital angular momentum, or a angular momentum, we can say. This is nothing but, I can say it as qi comma pi. Okay, so this is, it will takes the angular momentum that everyone know. This was the simple question. Okay, so let us move to the next question. See, this question, it is a wrong question. For this they have given the grace mark, and it is asked in 2024 case set. Okay, the options they have given to be wrong. Consider the following canonical transformations. They have given the three canonical transformation. We need to find which all the above transformation are canonical. See, let us take them first. First one. This problem was also similar, right? Like this only we need to do that problem also. So shall we do that problem? We'll solve one option, and we will get to know where they have did wrong. Okay, so they have given q to be half of the q square p, and p to be p divided by q. According to the canonical transformation formula, dou q divided by dou q and dou p divided by dou p minus of dou q divided by dou p and dou p divided by dou q, which is equal to 1. So partial derivative with respect to q, it will be half of the 2q into p. P remains constant here. Then partial derivative of p with respect to p. So it will be 1. 1 divided by q, right? Yes, it will be 1 divided by q minus of q with respect to p, means a half of the q square remains constant. Partial derivative q of with respect to p, it will be 1. Is it right or wrong? Yes. Next, p with respect to q. So p remains constant here. Q means minus 1 by q. It will be, if it goes, if 1 by q, it will be, if it goes upside, it will be q to the power of minus 1. Minus 1 into q to the power of minus 2 it will be. Is it right or wrong? That should be equal to 1. We shall see that LHS is equal to RHS or not. Q 2 get cancels, Q get cancels. What is remaining here? P is remaining. Minus of see here, q square minus q of to the power of minus 2 here get cancels. Minus of minus, it will be plus. What is remaining? P by 2 here it is remaining. That is equal to 1. Is it equal to 1? No, it is not equal to 1. So this equation, what we have, it is not the canonical. It is not the canonical. But see the options, in every option 1 is included. So the options are wrong. It is not the canonical, so the options are wrong. So they have given the grace mark for this. Thank you.